Welcome to 3 problems you should know on your SAT. I am a tutor for a college order organization, and I scored a 770 in my first math SAT portion. I'm taking it again in September, so you guys should probably listen up, right? Now, let's look at our first problem. 2 identical rectangular prisms, each have a height of 90 centimeters. The base of each prism is a square, and the surface area of each prism is k centimeters. If the prisms are glued together along a square base, the resulting prism has a surface area of 92/47K. What is the side length in centimeters of each square base? Okay, so every time you have an SAT problem that's like this, very wordy, geometric, you're going to want to draw out what you're told, okay? So, the prism has a height of 90 centimeters, so 90 here, and it's a square base. So let's just say one of these sides is B, which is what we're solving for, by the way. Now, we also totally have an identical prism that's stacked on top of it. So let's draw that. It has the exact same dimensions. So we're going to call this 90 B, B. Okay. So now our next step is to find the volume, or I mean the formula for the surface areas of these prisms. So for the smaller one, we're going to have B squared for the base, and we have 2 bases. So 2b squared plus, we're going to have 90 times b, and since it's a square base, we're going to have 4 of those. Okay, and that's equal to k. And that's our first formula for the surface area. Okay, so now it's like a formula for the bigger one. So our whole area, or our whole height here, is 180 in total. Okay, so let's find our formula. It's going to be 2b squared again, since it has the same base 2 times. And then instead of 90 for that, it's going to be 180b. And we're going to have 4 of those again. Is equal to, right here, 92/47k. Okay. So, now that we have these 2 equations, you could either solve this on paper, like a maniac, or you could just go to Desmos. Okay? So, to solve this on Desmos, you're going to need a double bracket regression. So, I'll go over this in another video if you don't know what that is. Basically, when you have a 2 system of equations, you can use double bracket regression. So we're going to retype our equations, 2b squared plus 90b, and there's 4 of those. Then our second equation, 2b squared plus 180b, there's 4 of those again. And the first one is equal to k. The second one is equal to 92/47k. Now you'll see it gives us just 0, 0. If this ever happens to you in any Desmos problem, just make a whatever this bracket's called, and then just make it like greater than 1, and that'll work, okay? So as you can see, our b value, or one of these side lengths, is equal to 8. That's going to give us our answer of b. So here's our second problem. In the xy plane, a parabola has a vertex of 9, -14, and it intersects the x-axis at 2 points. If the equation of the parabola is written in this form, standard form, which of the following could be the value of a, b, c? And a and b and c are all constants. Okay, so we don't need that as much for this problem. A lot of people overcomplicate this problem, and it's actually pretty simple. So let's start off by modeling what we know. All right. So we have a vertex at 9, negative 14. So 9, negative 14, which vertex will that be in? I mean, which quadrant will that be in? Well, 9, negative 14, it's probably going to be, we'll estimate right about there. It's in the 4th quadrant. And it intersects the x-axis at 2 points. So let's just say it's here. Doesn't matter where you draw them. Okay, let's draw that parabola. Not a very good one, but that's okay. All right. Okay, so we have that. Let's label that. All right. So the next part we're going to focus on is this a plus b plus c. Now, what is a plus b plus c really? In this case, a plus b plus c is really just when the value of x is 1. Okay, so let's say f of x equals ax squared plus bx plus c. Really, we're just inputting x as 1. Okay, so f of 1 is equal to a plus b plus c. Okay, so now I want you guys to think. If you look at these answer choices, there's 3 of them that are below negative 14. There's 1 of them that's above negative 14. We've already established that this parabola is opening upwards. Okay, so if it's opening upwards and 9, 14 is the vertex, that means that negative 14 is the lowest y value this graph can possibly get. So that's the lowest. So if you think about it, f of 1, let's say, just estimate f of 1 is right here. No matter what, it's going to be above negative 14. So what's the value of a plus b plus c? Well, we already know a plus b plus c is basically f of 1. So it has to be above negative 14. That's how we get the other answer. No Desmos needed, nothing. Very simple problem. Our last problem. A circle is inscribed in a square such that the circumference of the circle touches the midpoint of each side of the square. The length of the diagonal of the square is 256. What is the area in square units of the circle? Okay, so once again, this is a very heavy, word dense geometry question, so we're going to go ahead and model it. The square is inside the circle, and the diagonal of the square is 256. Okay, so the only way we're going to be able to find the area of the circle is to find this, which in other words is just one of these sides of the square. So, how do we find the side of the square? Well, we're told this is 256, and we know that a square is all 90 degrees, or all the corners of the square are 90 degrees, so that's 90 degrees. We also know that diagonals bisect angles in a square. So if all these corners are 90 degrees, bisected, they're 45. This is 45 degrees, this is 45 degrees. Now this is where our special right triangle comes in, okay? So if we have a special right triangle here, just pretend these angles are equal. 45, 45. The rule is that this is x, and this is x squared. X times the square root of 2. That's always the rule. So here we already have the hypotenuse, or the x square root 2. So the sides of these are really 256 divided by square root 2. Okay? So, now that we know the sides, we have the diameter of the circle. So we just have to divide this whole thing by 2 to get the radius of the circle. So now, for the area, what we're going to do, we're going to hop into Desmos, and we're just going to see we're going to type what we see. We're square root 2 over 2. That whole thing is a radius. And then the formula for the radius is r squared times pi. So we're going to square this value. Looks a little wonky here, but that is a square. And then pi. Now, we don't really need to know this value because all these answers are in pi. So just delete the pi. We will get 8192. As you can see, B matches up best. That's how it is. Hope you guys learned something from this video.